Hello, and today I'm going to be talking about the plan for the 8-bit computer that I'm going to be building alongside showing you the random number generator module that I've already designed, built, and tested. Firstly, I want to say that the support I got on that 4-bit computer series is amazing and I'm very thankful for it. I hope you stick around to the end of the 8-bit computer. Here's the architecture that I've designed for the computer, and it is a little convoluted at the moment, but as I go on with the project, it will hopefully become clear as to how it works. Notably, some of the coolest things I've added to improve upon from the last computer are the dedicated hardware for video output, random number generation, a stack for full support of functions, huge RAM upgrade, double bus design, and a modular system for the whole computers, which is similar to what Lilbits did with the Z180. I left a link in the description if you want to check him out. Now, let's take a look at the random number generator module, as it is quite simple, but very nice to have in the computer. The core idea for how it works is that the computer's clock ticks at a constant frequency, and so the random number generator has its own separate clock that ticks at a different frequency and counts up all the time. When the CPU wants to get a number, it just takes whatever is in the counter at the moment, but because the module's clock and the CPU's clock are not synced, the CPU can't really predict what number is going to be next, and so it is basically random. I have not yet ordered all the parts for the 8-bit computer, and so I will be testing these modules in their 4-bit form, but the logic is still the same, just less wires and chips. The new module also has a buffer register at the output, so once a random number is picked, it will stay there until a new one is picked, to avoid having issues in the future with timing. But in order to truly make sure that the module was generating a proper random distribution between all 16 possible numbers that it generates, I hooked up an Arduino Nano to the module and wrote a script that pulls 800 numbers from the module and counts how many times each number was selected. Because there are 16 possible numbers that the module can return and 800 polls, each number is expected to be about 50 times, because 800 divided by 16 is 50. If that isn't the case, then the module is not working properly. And after some bug fixing in my code, I ran it and saw that it actually worked. Each number was appearing about 50 times, which is exactly what I expected to see if it worked. So I hope you enjoyed this update and maybe learned something, and stay tuned for the next module.